Alrighty, page 13, we can go through together here. So first of all, these have like indexes and like radicands, so they can be added. Let's add 1 plus 7 is 8. 4 through 10. Alright, so that's an example of adding and subtracting like radicals. Well, those are both cube roots, but the radicands are different. So let's start by simplifying this. 54 is 27 times 2, and I know the cube root of 27. And now I have like index and like radicand, right? There's 3, cube root 2 minus 1, cube root 2 is 2, cube root 2. How about the 4th root of 32? That's 2 to the 5th, right? So about 16 times 2. And I know the 4th root of 16 is 2. So 2, 4th root 2, plus 6, 4th root 2. Just bringing that down. So then 2 and 6 makes 8. 4th root 2. Now that we have the same radicand, those are the indexes, the same radicand and the same index, we can add them together. All right, how about the square root of 8x plus 3 times the square root of 2x? Remember, if there's no index and it's implied 2, so 8 breaks down into 4 and 2. I know the square root of 4 is 2. So 2 radical 2x plus 3 radical 2x. Now I've got the same index and the same radicand, so I can add those together. All right, what do we have here? Well, let's put them in a root form first. So this is what Friday's quiz is all about. That's the 5th root of 8 plus 10 times the 5th root of 8. So there's 12 times the 5th root of 8. Same index, same radicand. All right, that goes back to what page now? Seems like we're jumping around a little bit, but that's the property from page 9. Okay, the same index and radicand. That's what we're applying now on page 12. So same index, but different radicand until we go and simplify. 27 is 9 times 3. And, now we're multiplying. So, there's 9, and that's 3 times 3. So if I rewrite the 4th root of 27 as 3 times 3 times 3, right? That's the equivalent of that. Then I bring down my 1 more. Isn't that 4 3s? That's what we're looking for, right? Whatever 27 times 3 is, 54. Or the 4th root of 54, 81. the fourth root of 81 is 3 because 3 to the fourth is 81, right? That's a check. So either way you do it, break it down first or multiply first, you end up in the same place. Let's break this one down first. What's 250 over 2? 125. Then take the cube root. That's 5. The fifth root of 3 over 4. Let's write that as the fifth root of 3 over the fifth root of 4. Now 4 is only 2 times 2. So I need 3 more 2's to get to 5. Right? There's 2 and 3 more will get me to 5. So if I multiply the denominator by that number, I should also multiply the numerator by that number. What's 8 times 3? 24. That doesn't simplify. But then in the denominator, I've got the fifth root of 2 to the fifth. That, you should know, cancels out to 2. So fifth root of 24. Good rationalizing the denominator problem. Here, same index, but different radicand. And now we're adding. So let's see, 40 is 4 times 10. Doesn't matter what numbers you pick to start with, you should end up in the same place. And look at that, there's 3 2's, right? So that's the third root of 5. Put that underneath. And the third root of 2 times 2 times 2 times 5. Look, there are 3 2's, and the index is 3. So that comes out as 1 2, cube root 5, and that other cube root 5 from out front. So we've got 3 cube root 5's. And there's page 13.